Greetings and welcome once again to the new calculus channel. My name is John Gabriel. So we talked about what exactly is a number in mathematics in the previous video. And there's been a lot of interest in this topic. And why is it important that we know that a number is a name given to a measure that describes a ratio of magnitudes? Because we realize number from the measure of a ratio. Okay. So this user here posts, though we are able to approximate incommensurable ratios arbitrarily close. Well, that's actually not true. In fact, even if you had 10 trillion significant digits, you would still be arbitrarily far away. Okay. In other words, it would be your accuracy is still close to zero compared to the entire representation of that number. Okay, so we need to call things by the attributes they possess, not those they do not possess, because well-formed concepts are defined in terms of attributes which they possess. So we don't say, for example, irrational number, because that's an oxymoron. Okay, to be a number, it has to come from a ratio. That's why you see the adjective rational. So just very briefly, how did you get the concept of number? Well, it all goes back to my brilliant ancestors once again. So what did they do? They started off with magnitudes, ratios of magnitudes. Now, so if, for example, you have something like that, and by the way, I could actually draw those as a single line, but I'm just doing that so that you can see what I mean. Okay, so let's say I have this. Okay, and all these. Now, this particular ratio here doesn't have numbers. It's just got magnitude. It's got this line and this line. So how do we get a number out of this? Well, we find a magnitude that divides both of these exactly. Okay, in other words, divides the antecedent and the consequent. By the way, that's what a ratio is. A ratio, we shouldn't be calling 3/4 ratio, because it's not. It's a number. It's a fraction. It's already past the measure stage. The measure stage is over here, where we say, okay, how do we measure this? Well, we count 1, 2, 1, 2, 3, right? So it'll be 2/3. That's what it means. Okay, so and 2/3 is a complete number. It's a name that we give to this ratio. Okay, it's a name that we give to this ratio. So going back to the comment, let's go back to the comment. So he says something we can work with as if it was a number. Well, that's what we do when we use the approximation, isn't it? And we do it in many cases when we want to calculate area, volume, etc. And so then he asks the question, why are ratios the deciding point? Because that's where number comes from. So he says he doesn't understand why ratios of measures should be treated differently, but they're not different. That's the measure of ratios are not treated differently. The measure of ratios result in a number. And I tried to explain this to him, and I said, well, we can work with the approximation as a number because the approximation is a number. Okay, so we don't say irrational number because that's an oxymoron. It's like saying irrational rational. Does that make sense? Okay, so ratios are foundational to understanding number. And if we have this ratio here, as I just explained, the Greek word for determining the number out of this comes from the word quotientness, okay, meaning can it be formed into a quotient where we divide each part by the same measure or the same magnitude? And so we count the number of equal blocks or equal lengths or equal masses in both the aliquot parts of the ratio. And that's how we get the number. So if we have the ratio circumference to diameter, we can only tell an approximation. In other words, the measure is not complete. There is no there is no magnitude that can measure both the circumference and the diameter. In other words, if this is, let's say, the circumference, and that's the diameter, there is no number that corresponds to this measure. Doesn't matter which circle you take, and we know that in fact the very fact that you can choose any size circle means that any diameter acting as a unit will never measure it. Okay, so because the diameter here is the abstract unit, do you understand? So why is it important that we know what the difference is between a ratio and a fraction? Because all numbers are fractions. And by the way, ratios came long before numbers, like I've just shown you. A ratio was normally just a comparison of two magnitudes or two line segments, right? That's all it means. There's no number there until you count up the number of equal divisors in the aliquot parts of a ratio, something which most of your moronic mathematics professors don't understand, because they're such fucking idiots who are ignorant, stupid, and arrogant and cannot be corrected. Okay, so there's no such thing as an infinite decimal expansion. That's just another myth, by the way. And of course, I've talked about this at length in other videos, so I'm not going to repeat myself. To know what is a number is very important, because mathematics is the abstract science of measure and number. Okay? If you're not already a subscriber, become one, click like, tell your friends about this, and also follow me on academia.edu. I'm John Gabriel, and this is the New Calculus Channel. Until next time.